Hi, welcome to my channel. In this episode I'm going to go through the very basics of electrical circuits used in automotive diagnostics. The aim with this video is actually, once you have seen it and understand what's going on, you'll be able to immediately apply it in your own little garage. Start doing your own measurements with a voltmeter as your favorite tool. I think we'll just jump right to it, and before coming too fast, I think we should get a little understanding about what is voltage, what is ampere, and what is resistance, and how they actually work together. What we have here is a battery, and we could make a little similarity actually. We could say that the battery is a water pump, and the voltage is the pressure which this pump can supply, and the ampere is the flow. And what this also means is that if we have this water pump and we put a water hose to it, and I'm gonna close, now we're gonna open the water, but I'm gonna press the hose so the flow will reduce. That basically means resistance is going up and flow will be reduced. And this is what Ohm's law actually states. It states that when the resistance in an electrical circuit goes up, the current, the ampere, goes down. And water flow, you could actually consider that electron flow also. And that's why the similarity with the water hose is actually quite good. So when you're in doubt how it actually works with ampere, resistance and flow, think about water which is flowing through a hose. And another thing, those two probes from your voltmeter, you don't necessarily always need to put one probe on the ground or on the zero and the other on your electrical component where you have the supply, 12 volts in this case. These two probes always measure the difference between each other. You could call it the pressure difference in whatever circuit you're measuring. In this circuit that we have here, we have a resistor here. I can measure across here or across a light bulb. And what you measure here is actually voltage drop. And we'll get into that in 2 seconds. Because there are 2 things that you can measure with a voltmeter. Either you can measure an open circuit, or you can measure a voltage drop, as I just said, through a closed circuit. Let's take the first example. If we have an open circuit like this one, we will always measure the difference between the supply, which is, I'm going to flip them around, 12.5 volt on the one side, and 0 volt on the other side. And since those 2 probes are always measuring the difference between each other, it's going to measure 12.5 volt. What is characteristic about an open circuit is that there is no current flow. You can consider this water hose to be broken. No water is flowing at all. No electrons are flowing. That's the one thing we can measure. The second thing is now voltage drop. And what this one measures is actually how much voltage drop is across this component. How much pressure this component uses. And this leads me to the next thing. Because in a serial circuit like this, you can be damn sure that when this circuit is done, all the supply voltage has been used up. All the pressure has been consumed by these 4 components. What happens is that we could measure 2.5 volts across this one, 2.5 across this one, 2.5 across this one, and then 5 volts across the last one. Because, how can I put it, each component will take their share of these 12.5 volt. And that's why you always need to have 0 volt in the end. Yes. So we will now go down and I'm going to do 3 table tests. We're going to do a simple serial test like this. Just try to measure voltage drop across each component. And I'm going to make after a parallel circuit which could mimic or look like a lightning circuit in a car. And then on the third one, I'm going to add a bad ground, a bad earth to one of the light bulbs, and then we can see how do we identify it. So let's jump into it, come on. Okay, so I'm gonna take off where we left, having a very simple serial circuit now. And what we have is, we have here our battery source, we have our switch, we have one load, in this case it's a light bulb, we have a second load, a light bulb, and then the final light bulb is connected to ground. And as stated, if we go and try to measure an open circuit, we can actually just measure it right here. We will always measure the difference between supply voltage and ground. 3.3 volt in this case, and I can take it also on the battery. It's exactly the same. This is an open circuit. No current is flowing. So what we will do now is we will turn on the switch, and you can see the light bulbs turn on. And we're going to do a voltage drop testing. And we can take the first light bulb, and then basically we can see how much voltage does this light bulb consume. If I could get it. All right, exactly 1 volt. Okay. And we can measure the next one. Almost 1 volt as well. So we are almost at 2 volts, and measuring the supply voltage with a closed circuit should be very similar to the 2 volts. And what you see is actually it's a little more the supply voltage than adding those 2 loads together. But that's simply the fact that a wire like this, the wire here, the wire here, the wire and the switch and this wire, everything is a load, and each part in this serial circuit will add or take their share of this supply voltage of 2.2 volts. So, and what we can do, we can actually take a voltage drop testing across a wire and actually see how much does a wire consume by pressing here. Actually even more relevant right here and here. And you can actually see a wire like this takes 0.013 volt. How about if I measure right here or here? It's a little more, you can see, and it's actually the same path on the circuit. I'm just measuring a little differently on our loads. So you can see each component in a serial circuit will always take their share, but in the end of the circuit right here, 0 volts should be. And that's how it is. So now we're going to take a step up. We're going to do a parallel circuit to mimic a lightning system on a car. Now we are moving on to a parallel circuit, which is a very simple lightning circuit in a car. So what we have is we have our light switch over here, and we have the left light, we have the right light bulb, and they are both connected to chassis ground through those wires here. So this is a parallel circuit, but each branch, you could say right and left, is considered a serial circuit. And we're going to turn on the light, and they are sharp. And the thing about a parallel circuit like this is that they should each get the same supply voltage, 13.5 volt, 13, and pretty much a half volt, very much similar. Each yeah, that's about it. So right now I'm gonna make another add on to this one. I'm gonna add a bad earth, and then we're gonna see if we can identify it by using the voltage drop testing. So now we have the same lighting system once again. We have our left light bulb, our right. We have our light switch here. Now we're going to turn on the light. And we can actually already see that our right light bulb is not as bright as the first one or the left one. So what's actually wrong here? So what we are looking at is we have a bad earth connection. There is something wrong, and you can physically see I have added a resistor right here. And thinking back of what I said, when we're using voltage drop testing, we can actually measure across a component, a wire, and see how much they consume. And also remember that in a serial circuit, when the component, after the last component, we should have 0 volts. So what we do know is that on the one which is working, we have 13.5 volt. It seems right, that light is very bright. But we only have 7 volts. Or 7.7 across the other one. So something is wrong from this side toward the chassis ground. So what we could do now is actually measure on the ground side of the light bulb toward the ground. And we actually measure 5 volts. So you can see 5 volts plus 7.7, and then somehow we are back to the 13.5 again. So if I were to measure from this one to ground, chassis ground, we would measure 0 volts, or almost 0 volts. And this is what it needs to be. So this is how to identify a bad earth. You can see, I'm going to do it again. 5 volts. Here we should measure 0 or approximately 0. And our light bulb is only consuming 7.7 volts. So there you have it, guys. Let's wrap it up. Okay, that's about it for now. I hope you enjoyed the video, and please feel free to write in the comments if you have questions or anything. I'll happily answer them. So stay safe and take care, everybody. Bye bye.